So far we looked at path length, we looked at why thinking parallelism is important versus just a single threaded or sequential thinking is not required or it's not good for designing applications. Now let's look at what is the impact of database connections, or what are the best practices or anti-patterns when it comes to database connections. Now what are database connections? As you would have seen in most of the applications, many of these applications work on some or the other information or data. So data manipulation is one of the key workload characteristics. So in order to go and access any of the data in the database, what does application do? Application first needs to establish connection to the database. And once it establishes connection, it can do some operation on it and then release the connection. Now with application servers in picture, we try to make efficient use of connection. That means we don't go to database and say every time, let me connect to you, because that's a time consuming thing. The application server can manage a pool of connections. And application goes and asks the application server, hey boss, give me one connection, I'm going to use it and release it back to you. And the good way of using this connection is an application goes, says get a connection, use it and release it. And that's so in a manner that it doesn't really hold it for a long time. I'll come to the implications of using it for a long time in future slides. But to remember is, it's important for application to get it, use it, and then release it. Now, why are we focusing so much on connection when it comes to performance? Now, the amount of time that you're going to spend in getting the connection and using it and releasing it has an impact on path length. And more so when concurrent users are using the system, because all the web container threads or all your transactions are going to come and ask for connection. If it's not used effectively, it's almost like waiting in the jam for your turn to come to go. That means the response time is going to increase. Now, what are some of the ways available to check the connection usage during development? Now, one of the easiest ways is to set the min and max number of connections on the data source to 1. Run the transaction that you're developing. See if the transaction goes through. If the transaction succeeds, that means an application is able to get a connection and it uses it. But there's no guarantee that it is releasing it. But there is a guarantee that it used only one connection. That you're sure about. Now what if, so you run the same transaction again. If there is a leak, your application won't be able to get a connection and you will get an exception, which is connection timeout exception. So you're sure that there is a leak using simple tests versus allowing it to happen, then going into production using any of the tracing to find out if there are leaks, etc. Now we also have an option in WebSphere application server, the option for JDBC connection tracing, using which you can know, even in the concurrent situations, what is the state of each connection, whether it's being used, whether it is free, or it is, somebody has taken it but not doing any work on it. There's also one more WebSphere administrative command, which is called a show pool content. Gives very similar detail to what you see in tracing. It dumps the details of all the connections in the pool, and it also provides the details of the state of these connections. So these three together, if you used, one can find out if there are leaks, if there are any incorrect usage of connections during development time itself versus this becoming critics later on. Now let's assume you are looking for a system in production and you do have some doubts about connection usage. What could be the quick indicators to tell you whether the connection usage is fine or not? One could rely on the PMI feature provided by WebSphere Application Server. PMI stands for Performance Monitoring Infrastructure. So the PMI infrastructure gives you counters such as database connection allocate count. It also gives counters such as database connection release counts. So using the difference of these two, one can find out if there are any leaks. If there are more allocates than releases, it's an indication of leak. The second important pattern that one can look at is see the difference or the ratio between active web container threads and active database connections. If you see that the web container threads are more compared to the active database connections, we are in an okay state. But if you see that the number of database connections are much higher than the number of web container threads, it's a clear indication that one thread is using more than one connection, which means they're either taking the connection, not releasing it, or they do what is called as get, use, and release only pattern. That means they actually use two connections versus two or more connections versus just one connection, which may not give the desired result. So to summarize this slide, even if you're in production, you can use quick indicators such as this PMI counters to get to have an understanding of these connections being used fine, or even in case of problems, these can be used to debug and find out is it because of connection usage. Now let's say a min and max is defined on the data source. That means only so many connections can be obtained to that particular database. Now what if someone or some thread requests for more connections? What happens? As per the JDBC specification, the connection will be timed out. That means a thread requesting for a connection will wait for the time specified by the connection timeout parameter. And even after that, it will get an exception from the container saying that connection timeout, which means the application should in turn go back to the user and say, please come and try again. Now, what are the implications of the connection timeout and how is it usually set? One of the very traditional way of setting connection timeouts is to base it purely on the response time target. So if the response time target for a use case is 3 seconds, one would say connection timeout should be less than 3 seconds. That means you shouldn't spend all time waiting for timeout itself, waiting for getting connection from database itself. But is that all? Now let's look at a scenario. You have 200 web container threads, but you have two data sources going to two different databases, and you have defined 200 as the max connections in both. If there is a problem in one database, all the 200 web container threads can be consumed because all of them are going to go and wait for connection, which means even the other database which is working, you cannot access it. It's because the road is full. Road is full because one side road is blocked. Even if the other side road is open, you can't move it because all vehicles came in and just stood there without allowing the other vehicles to pass to the other side road. So what is the better way of looking at connection timeouts? Better way of looking at connection timeout is to take a look at the request rate, look at the response time targets, and also look at the incoming rate of the request. Use all these three to effectively tell what should be the correct connection timeouts. One is to ensure that the user does not click on a button and keep waiting. The second one is to ensure that blockage on one side road does not prevent vehicles moving to a side road which is working. And last, very important point, do not forget to handle connection timeout in application, which means some applications do have timeouts at the application level. When connection timeouts happen, that timeout should be invalidated. That means you don't have to wait for, let's say, 3 seconds, 10 seconds expecting response because you know that you can't even go to the database. So go back and give the error message back to the user